Civil twilight hangs over the automotive terminal at Bremerhaven like a sheet of cold steel. At the berth, a wall of white rises from the black water, with a blunt, vertical scale that barely resembles a ship at all. In this aerial photograph, tens of thousands of vehicles are parked across the wet tarmac, waiting beneath high mast lights to board the vessel. Yet the typical sounds of a major port are missing. You won't hear the crash of heavy grabs or the shrieking of crane cables. There are no giant steel boxes suspended in midair. Instead of the violent labor of traditional hoisting, the terminal operates with the rhythmic hum of a highway. A heavy steel panel at the stern lowers to the dock, allowing the ship to exhale automobiles in a steady, disciplined stream. Most cargo ships operate like floating warehouses. Bulk carriers are built for loose grain poured into deep holds, while container ships are designed to slot standardized steel boxes vertically. The roll-on, roll-off, or RO ship, operates on a different rule. If the cargo has wheels, the fastest way to move it is to let it drive. Remove the cranes and let the cargo move under its own power. The vessel becomes an enclosed, multi-story highway system that happens to float. Designing for traffic rather than storage dictates the entire geometry of the hull. The shape of the stern is built around a massive ramp, and the interior is carved into long vehicle lanes divided by physical fire boundaries. This specialized efficiency makes the RO ship the invisible backbone of national logistics chains, connecting global manufacturing centers to local dealerships across oceans. This image shows a heavy steel loading ramp at the stern, connecting directly to a terminal structure called a linkspan. This interface compensates for tidal variations and berth geometry, turning land and sea into one continuous road. Inside, this photograph reveals how the ship's interior is divided into long horizontal vehicle decks. Strict lane markings and carefully angled internal ramps allow vehicles to move smoothly up and down the ship without gridlock. This diagram shows hoistable mezzanine decks. By raising or lowering these movable intermediate floors, operators can adjust the vertical clearance, allowing the exact same space to switch from tightly packed sedans to tall construction machinery. This photograph shows the military application of the concept. The U.S. Military Sealift Command uses large, medium-speed, roll-on, roll-off ships to move mechanized force across oceans, driving heavy tanks and tracked support equipment directly aboard. In this photograph, we see the solution for heavy industrial cargo that lacks wheels entirely. Port workers place static modules onto low-profile platforms called MAFI trailers. Terminal tractors then tow these units aboard, forcing non-wheeled freight into the flow of traffic. Through ramps, moving decks, and wheeled platforms, the traditional cargo hold is completely abandoned. The vessel functions as an active piece of industrial terminal infrastructure that happens to be seaworthy. Given the massive industrial scale of these ships, you might expect the loading process to be highly automated. In reality, it requires intense physical labor and the precision of disciplined traffic management. During a major port call, hundreds of human drivers take the wheel. Over many hours, thousands of vehicles are driven individually, routed up steep internal ramps under harsh lighting, and navigated into tightly organized stowage positions. Robotics struggle to navigate tight clearances, variable deck slopes, and shifting reflective lighting inside the steel hull. A trained port worker making continuous split-second decisions remains the most reliable navigation system. Once parked, the physical restraint begins. Workers wedge chocks against the tires and manually apply tensioned chains and straps to the chassis, locking the vehicles down against the pitching and rolling of the open ocean. The entire speed and success of this massive marine operation ultimately relies on manual physical labor and the judgment exercised in the last few meters of a parking space. The open deck geometry that makes the system so efficient also introduces profound risk. To maintain uninterrupted traffic flow, these ships lack the vertical, watertight bulkheads that keep standard vessels stable during a breach. This diagram illustrates what happens when water breaches that open space. Without walls to stop it, the liquid spreads rapidly across the broad deck. This triggers the free surface effect, violently shifting the center of gravity and forcing the ship into a severe lean. This historical photograph captures the catastrophic result of that exact failure. In 1987, the Herald of Free Enterprise left Seabridge with its bow doors open. Seawater flooded the undivided car deck, and the vessel rapidly capsized, killing 193 people. Today, the threats extend beyond water ingress. Closely packed vehicles, fuels, and plastics create severe fire hazards. The rapid increase in electric vehicle transport has introduced lithium-ion battery fires, which generate intense, sustained heat and can be exceptionally difficult to suppress deep inside these enclosed steel lanes. The Ro-Ro ship represents a triumph of logistical speed, but the lack of compartmentalization means it operates with a razor-thin margin for error compared to more traditional designs. Back at the terminal, the final checks are complete. The stern ramp slowly folds upward, hydraulic locks engage, and the active roadway is sealed back into the armored hull of an ocean-going ship. Looking at the Thruxton in this photo, the logic of the Ro-Ro world is fully realized. It is a highly tuned machine devoted entirely to moving wheels and axles across the globe through the simple act of opening a door. But at the adjacent berth, a completely different maritime logic is taking shape. There are no heavy ramps or axle load calculations. Instead, the focus shifts to gangways, illuminated spaces, and internal architecture built to meet human expectations. We leave the industrial parking lanes behind. In our next episode, we look at the engineering and safety demands required when a ship's cargo walks aboard carrying its own luggage.